So let's look at this application problem. Iron Man is buying some new parts for his suit. Okay. Photon blasters cost $3 million each, and biometric analyzers cost $5 million each. Iron Man has budgeted $30 million for upgrades. Write an equation in standard form that shows the possible combinations of upgrades he can buy. So we are, sorry, excuse me. We are used to writing applications in slope-intercept form, where we had an initial fee or initial something, and then a constant rate of change. But here, we have two variables, photon blasters, the amount of photon blasters he could buy, and the amount of biometric analyzers that he can buy. Okay? So, we kind of have a rate for each of these. Photon blasters cost $3 million each. Okay, so I take the amount of photon blasters that he buys, and I have to multiply it by 3 million. Okay? And biometric analyzers cost $5 million each. So I take the amount of biometric analyzers that he wants to purchase, and I multiply it by 5. He has budgeted $30 million for upgrades. So I take the amount of photon blasters that he buys, I take the amount of biometric analyzers that he buys, and when I add those together, it has to equal $30 million. Okay? So his budget is 30. So the equation of this line would be 3 times the amount of photon blasters, or $3 million times each photon blaster, plus 5 million times each biometric analyzer, and that has to equal his budget, which is $30 million. Okay? So my x-axis, if I go to my graph, my x-axis represents the number of photon blasters, and my y-axis represents the number of biometric analyzers. Okay? So if I wanted to graph this, I would need to find the intercepts. All right? So if I found the intercepts, P0, okay, because P is playing the role of my x, I'm going to plug in 0 for B. I get 3P equals 30, so P is equal to 10. So my P-intercept is 10, 0. Okay? My B-intercept, B is playing the role of my Y. I plug in 0 for P, and I solve this for B. So I get B equals 6. Okay, so my B-intercept is 0, 6. So if I were to graph these, the number of biometric analyzers on the y-axis, which is kind of my B-axis, 1, 2, 3, 4, 5, 6. My P-intercept, where it is on the P-axis, which is playing the role of my x-axis, be at 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then all I need to do, connect these two. All right, that is the graph of this function. Now, explain what these intercepts mean. So for the x-intercept or the p-intercept, this 10, 0, that means if he buys all photon blasters, he can buy 10. He can buy 10 photon blasters if he only buys photon blasters. So if he spends no money on biometric analyzers, he can buy 10 photon blasters. All right? The B-intercept, or your y-intercept, is 0, 6. This represents if he only buys biometric analyzers, he can buy 6. Okay? So that's kind of a word problem. Word problems lend themselves to either being slope-intercept form or in standard form. Okay? So if you see two different variables kind of with their own rate, $3 million each, $5 million each, okay? That's most likely going to be a standard form equation. Okay? Make sure to tune into the next video to learn how to write these equations in different forms.